So yeah, I want to talk a little bit today about the role of 5G in IoT, and a quick overview of what I'll share in the next 15 minutes or so. Start by talking about some of the key characteristics of 5G networks, and then look at how those can assist in IoT use cases in general, and take a little bit more of a detailed look at the agri-tech and smart energy sectors, which is a couple of the verticals where BT is currently active, not exclusively, but a couple of them, and then finish with a quick look at what the future may bring. So new IoT requirements are emerging and will be addressed by 5G as network demands essentially become more demanding based on those new requirements. This diagram shows the key characteristics of 5G and may be already familiar to some of you. Essentially, there are three key features that 5G technology brings. Massive machine type communications, so the ability to have tens of thousands of devices in a relatively small area and have a mobile network that can cope with that. Ultra fast mobile bandwidth, up to 10 gigabits per second mobile data, and ultra reliable and low latency communication. So networks that don't drop out and that can respond in milliseconds to certain events. So just to go into a little more detail on that, you can see there again the three key features: massive MTC, mobile broadband, and reliability and low latency. And if we look over on the right of the screen there, we can see that over time 5G IoT is clearly an evolution essentially of previous generations, and as new demands have come along on networks, then new features have been added to deliver against those requirements. I guess the interesting thing there on the right is that as far as the cons of 5G go, I guess we don't know yet, but no doubt 6G will come along and help to address whatever they may be. So I've already mentioned some of the stats here. You know, we're talking about a peak rate in terms of mobile broadband of 10 gigabits per second. We're talking about as low as a millisecond of latency in some instances. And we're talking about potentially 1 million devices connected per square kilometre, each with a 10-year battery life. So low power consumption is obviously a key feature for IoT to be more of a practical proposition. And there are essentially three kind of connectivity options for IoT, airless connectivity options: NB-IoT, LTE, also known as Cat M1, and 5G NR. So NB-IoT and Cat M1 can be taken as part of 5G, and then 5G NR will coexist with those. And broadly speaking, NB-IoT and LTM kind of address massive machine type communications, that connectivity, mass connectivity issue, and 5G NR will address the mobile broadband and low latency issues. I mean, there are other networks as well. So for example, there's LoRa, which is unlicensed spectrum, and that has very low power requirements, for example. But in broad terms, this is the way we can think of 5G deployments or technologies to deliver the three key features for excuse me, for 5G. This one is looking at that in a little more detail, and the IoT performance requirements that you have will tend to define the most appropriate type of radio interface, be that NB-IoT, LTM, 5G NR, or even LoRa, or other features or other technologies, as we've just discussed. And I won't go through that in great detail given the time available. So this is another way of thinking about that. The idea is that you can distinguish between massive IoT and critical IoT. This diagram came from Ericsson, and in broad terms, with massive IoT, you're looking at low cost, low energy requirements, relatively small data volumes, and massive numbers of connected devices. And there, LTE, NB-IoT would be particularly appropriate. With the critical IoT on the right-hand side, however, we're looking at ultra reliability, extremely low latency, and very, very high availability. And if those are the features of your domain of application in the critical IoT space, then 5G NR may be more appropriate. I mean, this isn't an exact science, but you know, there might be obviously applications which are both massive and critical, but nevertheless this gives you a feel for the kind of networking technologies and the kind of approaches that are becoming possible with different 5G radio access technologies. So let's turn to some specific use cases. We can think of all kinds of different all kinds of different verticals in which we may wish to apply IoT and 5G technologies, and 5G technologies become particularly appropriate in some of the specific use cases. So in smart cities, for example, we've got surveillance and public warning systems, emergency operation, first responders, platooning, this idea of getting whole platoons of vehicles to move in sync automatically. Similarly, automated valet parking. And some of the network characteristics of 5G will certainly be required to reliably deliver some of those. Precision agriculture, I'll say more about in a moment, especially around the fruit and vegetable picking aspects, but there are other aspects as well. Smart farms, sometimes called somewhat tongue-in-cheek the Internet of Cows, smart irrigation, so irrigating based on you know, real-time data about the current situation in terms of crop conditions, soil moisture, and so on. Toxic level, gas monitoring, and so on. Smart energy I'll also touch on again, but as we move into more prosumer, highly dynamic ecosystems of providers and consumers of energy, 5G networks become particularly important. Similarly, network monitoring using drones to perhaps to use video analysis over a network. I mean, a physical energy network, not a telecoms network in this context. You know, that's going to need massive broadband to get that video and to analyze it. And as I say, more about that as well later. Smart factories, clearly many of the processes in smart factories are time critical, and we're starting to see the emergence of new technologies made possible by the kind of network characteristics that 5G offers. So haptic communications, which effectively allow you to wear a smart glove, which will then let you operate teleoperation, as the phrase goes, operate different machines from afar, with a much greater degree of automation than currently, but with operators diving in with kind of haptic control when required. Similarly, mining and offshore rigs, there's a requirement for underground and hard to reach locations there, and 5G offers a greater prospect of network coverage than previous generations of mobile technology. Another IoT application area, assisted living, so keeping people in their homes longer and more safely. And there's a number of different use cases within that. So helping visually impaired people to walk around cities, or firefighters in environments with reduced visibility. Wherever visibility is reduced, we can start to use haptic feedback to help people, to give people nudges as to where to go. And we can use things like, as you can see on the screen there, devices in shoes, effectively, which will vibrate and tell you to move left or right. Similarly, Ford have an ECG system to provide heart checkups while driving. So if you're about to have a heart attack, that would be good to know when you're in the car, and can monitor all kinds of other health. Continuous health monitoring in the home is another one. Home consultations, if a consultant wants to look at part of your body in detail without you having to leave the home, there might be an opportunity there for very high bandwidth images and videos to be sent across the internet using 5G. Similarly, individuals can wear many different types of low-powered devices to provide information about vital signs. Have you had a heart attack? Have you fallen over? And so forth. So many different kinds of application in this whole assisted living area, requiring all the different features of 5G. Okay, let me come on to perhaps in a little more detail what we're doing in agri-tech and 5G at BT. One of our projects is called Robot Highways. This is a collaborative project with University of Lincoln and various others, part funded by Innovate UK in the UK. And if we think about agriculture, back in the 1980s, fruit picking looked a bit like this. And in 2020, it still looks a bit like this. So it's still a pretty manual process. Not much has changed in the last 40 years. Similarly, I live in East Anglia. You can, this time of year, you can drive along the A14 and you will see hordes of people picking cauliflowers and other fruit and veg. So again, still a very much a manual process. And those, if you like, were the known knowns. We know it's a highly manual process. The known unknowns are events such as Brexit and COVID-19, both putting pressure on the agri sector and raising questions about food security and cost. So we have things like large farms hiring aeroplanes and sending them to chartering aircraft, sending them to Romania to bring fruit pickers over. And is that really a long-term solution, to go with that highly manual approach where the people doing the manual work have to be carted around Europe at significant cost? So the key question is, how will labour shortages or changes to the labour supply impact the business? And the key messages we get back from the agri sector are that there is real concern, that they are very interested in all solutions, including automation, and they are hoping and anticipating that automation is going to mitigate the impact of labour shortages and other issues within the next 12 to 18 months. So what they're saying to us is, yes, we can fly people over from Romania for a while, but not in the long term. In the 2-year plus time frame, that is probably not going to be an ongoing feasible solution. So to replace those people, robotic solutions are obviously key, and we're working in this Robot Highways project with a number of partners. As I mentioned, University of Lincoln are leaders in this space, but also Saga Robotics, who are among the leaders in the development of robots specifically to perform agricultural tasks. So I think I've covered this. There's an urgent need to support industrialization, automation and scaling in agriculture. Robotic solutions are key to that. And we feel that 5G is going to play a leading role here, partly because low latency is critical for actuation, for telling robots to do things essentially, and also for other aspects of this kind of scenario, such as many different devices and the need for sending potentially high bandwidth video over the network to allow for things like crop analysis. Here's this kind of robot that we're going to be using, and I won't sort of dwell on that particularly given the time. Yeah, moving on. So what are we going to be looking at specifically? What kind of things do we hope we can do? We're going to be looking at fruit detection, so we can start to count fruit and understand how ripe that fruit is, and thereby forecast the crop. We're going to be using robots for disease control. They can shine UV and other light spectra on plants, which is beneficial, and can spray plants autonomously. And that can be done at night, and that can be done entirely automated and take a lot of cost out of the loop. Fruit picking is more challenging, as you can probably imagine. Getting a robot to pick fruit without squashing it and pick it reasonably quickly. If you've seen a human picker, the experienced ones do go very quickly. So that's an area that's really challenging. And then there's support for robot logistics. How do we get from the robot, take the robot to the packing house, get the fruit integrated, packed onto pallets, and so forth, and how do we automate that whole process? So a lot of interesting use cases in the agri sector, and in robot highways we're looking at an integrated approach. One of the things we're very interested in is renewable energy sources, actually. So we want to provide EV docking stations for the robots using renewable energy, powered by renewable energy. Then, as I said, we have a fleet of autonomous robots doing a range of different tasks, including forecasting, picking, transporting, pest control, and so forth. And then you can see some of the BT role there is to provide a 5G network. We're kind of looking at a hybrid cloud edge infrastructure. So one of the interesting questions to come out of the project, I think, will be, what processing can you do at the edge, and when do you need to send a lot of data quickly to the cloud? So, for example, what is the level of video analytics we can run at the edge of the network rather than sending across the network to the cloud? Can we, for example, do video analysis as a robot moves up a row of plants to do crop analysis, crop condition monitoring? So what we're anticipating is it will be a hybrid cloud edge architecture, and it will need a 5G network to make that feasible. And we're looking at using a mobile 5G capability, which looks something like this, and will be able to be delivered to a farm or a rural location to provide 5G networking capabilities. And one of the interesting things I think that might come out of this is the ability, if it's feasible and costs in for a farm to buy this kind of networking capability, can we then use that more widely in that rural location to support other consumers and businesses in the region, in the area where it's deployed? So moving on quickly, a glimpse of the future. I think we'll see this kind of hyper connectivity will offer the capability for AI to disrupt, to be quite a disruptive technology in IoT and in 5G applications. And 5G has a potential to extend the cloud to the mobile edge, in a sense, so we can move things between the network and the near network and at the edge and the public-private cloud, because of that reduction in latency. Again, we can also push the AI complexity to the edge to use higher processing capabilities and less restrictive power budget. So it's going to be very interesting. It's back to this thing I was talking about just a moment ago. I think this edge cloud hybrid architecture and the trade-offs around that are going to be very interesting. So on the one hand, we'll have 5G networks which will offer high data transmission capabilities, but we'll also have increased processing power potentially at the edge, and there'll always be a trade-off between what you send to the cloud and what you try and process at the edge. There'll always be a need to send stuff to the cloud, I believe, if nothing else, to build historic data such that we can build predictive models. You'll need a cloud-based data center storing that kind of information. So there'll always be both of those will always be required, but I think it's going to be a key interesting trade-off for IoT in the years ahead. I mentioned briefly tactile internet earlier with haptics. I think we'll see a growth in haptic technology that will be enabled by 5G. I've mentioned there, the use of network slicing to improve the reliability of haptic delivery. You need ultra reliability that 5G offers. Obviously, if you've got a surgeon potentially doing remote surgery, you can't have the network going down, and you obviously need very low latency in some of those kind of application areas. So I think we're going to see 5G, those network features of 5G increasingly enable these kind of haptic interfaces in the future. So I'd like to thank everybody for their time. That was a relatively quick look through the use of 5G in IoT scenarios and some of the things that 5G potentially makes more possible as more complex IoT application scenarios start to emerge. So thank you very much.
So thank you. That was really interesting. And I'm just wondering, because there's a lot of investment required, which might be okay if you're a really large scale, but maybe trickier if you're not. How much do you think the pandemic, and also in the UK's case, Brexit is going to have will accelerate these kind of deployments? What do you think?
Yeah, I think that's a really good question. I think so. I mentioned the idea, in the rural context, that a large farm, it might be scalable and affordable and make investment sense for them to put in a 5G network, and there might then be an opportunity for them to work with the operator to kind of resell, in a sense, that investment that they've made into the wider community. So SMEs or even consumers might be able to benefit from that network investment. Similarly, you might see if there's a community of smaller farms, it might become worthwhile for them to sort of jointly make that investment. And again, we could see it's kind of an interesting commercial model there, where there would be a joint kind of go-to-market with an operator and like the anchor tenants, if you like, the anchor tenants for the network. And some of those discussions are ongoing and are starting to emerge. And I think Brexit and the pandemic will certainly have accelerated interest in some of those kinds of models. But I think it's at very early days, so we'll see. There's lots of possibilities that might yet emerge.
Well, John, thank you very much. Always a pleasure to have you.